Mountains, these towering giants of rock and ice, have captivated humanity for millennia. Their snow-capped peaks pierce the clouds, their slopes are cloaked in verdant forests, and their rugged faces bear witness to the relentless forces of nature. But have you ever wondered how these majestic landforms came to be? Mountains are not merely random bumps on Earth's surface, they are the products of powerful geological processes that have shaped our planet for billions of years. These processes, driven by the Earth's internal heat, constantly reshape the Earth's crust, creating mountains, valleys, and everything in between. Understanding how mountains form is like piecing together a giant jigsaw puzzle. It involves studying the movement of Earth's tectonic plates, the forces that cause rocks to bend and break, and the erosional processes that sculpt mountains into their distinctive shapes. Join us as we embark on a journey to unravel the mysteries of mountain formation, exploring the forces that have sculpted some of the most awe-inspiring landscapes on our planet. To comprehend the formation of mountains, we must first delve into plate tectonics. Imagine Earth's outer layer, the lithosphere, as a giant jigsaw puzzle composed of tectonic plates. These plates constantly move, driven by Earth's core heat. The boundaries between these plates are where the real action happens. Most mountains are born at these boundaries. At convergent boundaries, plates collide head-on. This collision causes the Earth's crust to buckle and uplift, forming mountain ranges. The Himalayas were formed by the collision between the Indian and Eurasian plates. At divergent boundaries, plates move apart. Magma rises, creating new crust and forming mid-ocean ridges. Over time, volcanic activity can build mountains, forming islands like Iceland. Fold mountains are formed by the folding of rock layers within Earth's crust. This happens when two tectonic plates converge, causing rocks to buckle and deform. Imagine pushing two sides of a tablecloth together. The fabric wrinkles and folds similarly. The Himalayas, stretching over 2,400 kilometers across Asia, are a prime example. Formed by the collision of the Indian and Eurasian plates, these peaks rose over millions of years. The Appalachian Mountains in North America are another example. Though not as tall as the Himalayas, they were once much higher. Erosion has worn them down, but their folded layers still show the tectonic forces at work. Fold mountains feature long, linear ranges with parallel valleys and ridges. Fault block mountains, unlike their folded counterparts, are formed by the fracturing and displacement of Earth's crust along faults. Faults are fractures in the Earth's crust where rocks have moved past each other. When tectonic forces pull the crust apart, it can create a series of faults, causing blocks of crust to either rise or fall relative to each other. The uplifted blocks form fault block mountains, while the downdropped blocks create valleys known as grabens. The Sierra Nevada mountain range in California is a prime example of fault block mountains. These majestic peaks were uplifted millions of years ago along a massive fault called the Sierra Nevada Fault. Another impressive example is the Basin and Range Province in the western United States, a vast region characterized by alternating mountain ranges and valleys. This distinctive landscape was formed by the stretching and faulting of Earth's crust over millions of years. Fault block mountains often have a distinctive asymmetrical profile, with one steep side and a more gently sloping side. This asymmetry is due to the tilting of the fault blocks during the uplift process. Section 5. Volcanic mountains, fire and fury, forge peaks. Volcanic mountains, as their name implies, are formed by the accumulation of volcanic materials such as lava, ash, and cinders. These mountains are born from the fiery depths of Earth's mantle, where molten rock, known as magma, rises to the surface through vents and fissures in the Earth's crust. Volcanoes can erupt explosively, spewing ash and gas high into the atmosphere, or they can erupt effusively, with lava flows cascading down their slopes. Over time, repeated eruptions can build up massive mountains, some of which rank among the highest and most iconic peaks on Earth. Mount Fuji in Japan, with its graceful symmetrical cone, is a classic example of a stratovolcano, formed by layers of lava and ash. Mauna Kea in Hawaii, on the other hand, is a shield volcano, built by countless eruptions of fluid lava flows. Volcanic mountains are not limited to land, they can also form underwater, creating volcanic islands. The Hawaiian Islands, for example, are the tops of a massive underwater mountain chain formed by volcanic activity over millions of years. Section 6. The Sculptors of the Peaks, Erosion's Role. While tectonic forces are the primary architects of mountains, erosion plays a crucial role in shaping their final form. Erosion is the process by which wind, water, ice, and gravity wear down and transport rock and soil. Rivers and streams carve deep valleys into mountain slopes, glaciers grind down peaks and carve out U-shaped valleys, and wind-blown sand and ice blast away at exposed rock faces. Over millions of years, these erosional forces can dramatically alter the appearance of mountains, carving them into jagged peaks, rounded domes, and everything in between. The Appalachian Mountains, once towering peaks rivaling the Himalayas, have been sculpted by erosion into their current, more subdued form. The Grand Canyon, a testament to the erosive power of water, cuts through layers of rock that were uplifted millions of years ago. Erosion not only shapes mountains but also plays a crucial role in the rock cycle, breaking down rocks into sediment that is eventually transported to the oceans and can form new sedimentary rocks. Section 7. Mountain giants, Himalayas, Rockies, and Appalachians. To truly appreciate the diversity of mountains, let's take a closer look at three iconic mountain ranges: the Himalayas, the Rocky Mountains, and the Appalachian Mountains. The Himalayas, Earth's highest mountain range, are a testament to the immense power of tectonic plate collisions. Home to Mount Everest, the world's tallest peak, the Himalayas continue to rise today as the Indian plate pushes relentlessly into the Eurasian plate. The Rocky Mountains, stretching for over 4,800 kilometers or 3,000 miles from British Columbia to New Mexico, are a relatively young mountain range, formed around 80 to 55 million years ago. The Rockies were uplifted during a period of intense tectonic activity known as the Laramida orogeny. The Appalachian Mountains, in contrast to the Himalayas and Rockies, are ancient mountains formed over 480 million years ago. Once towering peaks, the Appalachians have been sculpted by erosion into their current, more rounded form. Despite their age, the Appalachians still hold valuable clues to Earth's geological history. Section 8. The everlasting dance mountains in motion. Mountains may seem like permanent fixtures on Earth's surface, but they are in a constant state of flux, shaped by the interplay between tectonic uplift and erosion. As tectonic plates continue their slow dance, mountains will continue to rise and fall, their majestic peaks a testament to the dynamic nature of our planet. Understanding how mountains form and evolve is not just an academic exercise, it has practical implications for our lives, from predicting earthquakes and landslides to finding mineral resources and understanding the impact of climate change on mountain environments. So the next time you gaze upon a majestic mountain range, take a moment to appreciate the millions, even billions of years of Earth's history etched into its slopes. Mountains are not just beautiful landscapes, they are windows into the deep time and powerful forces that have shaped our planet.